Hello there. In this video, we're going to look at how do we use the electrical timers into real application. If you remember, we had a pneumatic circuit to control a bucket shaker or vibrator for the pen, right? So back then, the circuit we have is the purely pneumatic solution. Right? There's no electrical involved. So now, once we learn the electrical timers, we can try to use electrical control to replace the logic process. So by doing that, we have to make some changes on the pneumatic circuit as well. So we're going to keep the same cylinder. It's the same as that, right? The only thing the most important thing on the control on the pneumatic is that this was the air pilot control valve, right? So we change that into electrical control by solenoid Y1 and Y2. So that's what we call electro pneumatic. Then we keep the same regulator on here. Then that's it. That's all we need for the pneumatic circuit. So all the rest by the pneumatic process, we can use the electrical component to replace them, right? So that's what we will look at on the next slide. All right, so let's look at the circuit. Okay, so first let's talk about when we trying to design the function. We have to make some choice with one scenario. So what we're gonna do with the holding button? What I mean is that if the operator keep pressing the button after first time, normally people will just only press button and let it go, right? But if the operator keep pressing the button, holding that down, what we gonna do? So we can look at the first option. We can call the fixed length. That's basically represented by this timing diagram. For example, over here, you can see the push button being pressed very brief time, and then after that we start the timing. For this example, for the timing diagram purpose, only set up at 3 seconds. Of course, you can set up any time, a long time you want, right? So that's what I mean by fixed length. So this brief close being pressed, the button only start for 3 seconds on the timing delay, and then you can see on the after 3 seconds. We finish the timing. So if the operator pressed the button for the second time, right? But this time the button being pressed and hold for a very long time, even longer than the timer setting. The timer, if we set up at 3 seconds, on this one you can see the button being held for 4 seconds. All right. So in this situation, we can just say, okay, no matter how long you press the button, we will have a fixed length of the timing, still 3 seconds. Even though you're still holding the button, after 3 seconds, the timing finish. Right. So we'll look at the other option on the next one. So we'll look at the first option. So in order to be able to process situation like this, being pressed very brief period of time, we have to introduce some other device, right, with control relay. So let's look at here. Basically, that's the control relay out here. So maybe it's better to have both slides open in the same time. All right, just give me. Okay, I think this is better now. Okay, so let's look at the design on here. On the run 301, you can see this is a electrical limit switch. I use the label to represent the positions on the cylinder, right? 1.2. So that's on the retract position. So whenever this limit switch, which is open, right? Normally open, right? When it's being pushed close, that means cylinder is back to the retract, and then you want to extend. So that's why you need energized Y1. Y1 corresponds to this side, and if you twist the pneumatic circuit, right, the air will go in, take this path, and then I think somehow I got backward, but anyway, so this is just what I want to represent. Alright, when the 1.2 energized, you want energized Y1 to extend the cylinder. Alright, when you have the 1.7, or you can see here with electrical parallel with any one of those two limit switch being closed, that means we start at here, right? And then in between we just vibrate, oscillate between these two positions, right? Then eventually we'll go back to 1.9. So that's why we wire these two limit switch in parallel. So that's similar to this, right? So this is one side, and this is OR on the pneumatic, but we want to use electrical. Right? Obviously, this is a better solution than purely pneumatic. Then let's look at the most important part on the timing. So the timing, as you can see here, we start from the push button on 1.3, and then let's start the whole process we talked about before in a different video. And same thing here. So we have this normally open push button, and in order to have this brief period of time being hold on, we need to have a parallel branch. So we learned that in the 3-wire control, right? So we can use a contact to bypass the push button. So that means we have to bring in a control relay. So this is the CR1 control relay on here. So when the button being pressed down for the brief period of time, the current will flow through here, right? This is a timer on delay, normally closed, time open, right? It's normally closed, that will be passed over here. Then energize the timer, and in the same time energize the control relay as well. So both timer and relay will be energized in the same time. And relay doesn't have a relay doesn't have a delay function. So the moment being energized, this one become closed. So when it's closed, so that will bypass the push button. So but the button can be released now. So that's why we can use this to handle that. Right? Then you can see here, this is what we call normally closed time open. So normally it's closed, right? Before the time period finished, it's closed. But when the time finished, it will become open, timed open, right? So that will cut off the current to go into the timer and the relay. So that finished the timing. So in this way, so let me clear that a little bit. So you can consider this relay on here. It's like indicator of the timer timer is running. So later on you can see in PLC it's called timer timing, or you can simply understand that as to indicate the timer is running, right? So because of that, we can use this contact from the same relay, right? The second set, right? This is -1, this is -2, to represent when the timer is running. When the timer is running, then we can energize the Y2 as long as those two limit switch, one of them become closed. So that will push the cylinder backward. Alright, so let's just look at the demo. I have the video on the on here. I already finished the okay, so sorry. Okay, sorry. Yeah, it's a short video. Sorry about that. So as you can see on here, we have the electrical connections, right? That's the push button I use, and then there's a on delay, that's the coil, and that's the contact, right? Normally close, time open, right? That's the symbol. This is the IEC standard. Then also I use a control relay, right, according to the circuit. So I build it on there, and this is on the electrical circuit part, right? Let's look at the second part on the. Okay, so let me explain on here, right? So this is the double solenoid valve, right? And I use a one-way flow control valve to control the air going to the cylinder. So the cylinder has 3 positions being detected, and over here the retract is done by a limit switch, and I also use 2 3-wire sensors. Right? This is a both of them are photo sensors. So this one to detect the fully extended position, and this one you can see here is detecting in the central position, intermediate position, right? So the cylinder start from here and then go back, then go between these 2 positions, all right? So that's what you will see. Eventually it will extend back to the fully extended position, all right? Let me play the video. So you can see the sensor on, and that being activated by the limit switch, and then finish at the extend. All right, let me play that again. So it's on. It was on at the beginning, and then between these 2, eventually will finish and extend. So that's done by the electrical timer, right? So that's the circuit on here. All right. Remember, I talk about we have 2 different situations with the timing. So that's what we call the fixed length. So if you look at the pneumatic solution, let's look at the pneumatic solution on the previous slide. So if you have the operator keep pressing this button, all right, so let's see over here, right? So if you have that keep pressing button, so that means this side of the pilot light, the pilot will control keep pushing in this way. So that means the air will keep feeding to this part. So that means there's no way even the timer expired can push the valve to the left hand position, because it's a double pilot, right? So we learn that if we have both energized, the valve can stay in the position as before. So this is the design. I don't think it's a very good design, but this is what it was before. So if we want to use the same design, let's have some challenge, right? So if we want to have this sort of extended length, what I mean is that, so when the button pressed briefly, you give that 3 seconds, whatever you set up with the timer, that's same as this one, right? 3 seconds. And then if the operator press for the second time, for this time, if for example operator press for 4 seconds, so after 3 seconds the timer finished, you still want to go 1 more second on that. So if you want to keep the same design, what do you want to do with the current design on here? All right, so let me get the secret. Okay, so one thing you can see here, right, as I just explained before, CR1 represent the timer timing, right? So that can provide for the 3 seconds for sure. Then if we want to give the actual 1 second, as long as the button being pressed, we can have a parallel branch on here, right, to bypass this timing. So what we're gonna do, put it over here. So for example, you can use, if your button is multi-pole, right? You have another pole, of course you can put a button on here, right? The other pole, right? But sometimes the button doesn't have a second pole, right? So that's what we talk about. We can use a relay. We can use a second relay, CR2-1. So where is the CR2? So we can have this button. So I'll keep using the same label, PB 1.3. We use this button to control a coil on a different relay, and this one is CR2. And that's one set of contact being bypassed, provide the actual 1 second if the button being pressed. And then over here, so because we use that to control the relay, so we can use another set of contact from the CR2 -2, right? So then, because as you can see here, that's the cross reference, right? Because the CR2 contact being used on the 302, right? 302, 305. So I can write out here 302 as the reference, 305. So in consistent with those cross reference, right? So that will give you the actual length on the timing, right? So that gave the 3 second. This gave the extended whatever you have on that. All right. Okay.